Hello, and welcome to Section 3.3 Notes Dividing Polynomials. There are three different methods that we're going to talk about here. So for part one video, we're going to talk about what I like to call the split 'em up method. It's not really a name, but right here, split 'em up. But the key for this is you got to know when to do which kind. So we're going to talk about split 'em up. We're going to talk about long division. We're going to talk about synthetic division. So the split 'em up method is strictly for dividing by a monomial. So this guy down here on the bottom of this example problem, he's a monomial. It doesn't say 3 plus x. It doesn't say 3 minus x. It just says 3x, one term. So if you think about it, you ask yourself this question, what's being divided by 3x? Well, everything on top is. So really what we want to say is it's like three problems to do. So I want to take the 9x cubed and divide him by 3x. I want to take the middle term, divide him by 3x. And I want to take the last term divided by 3x. Now, technically, you don't have to take the time to split them up like I've done in this example, but I still recommend it. The reason I recommend it is because once you write it this way, it just becomes three little individual problems to do that we have already talked about in a previous section. So how do we do division of monomials? Well, we divide the coefficients. So there's a 9 and a 3. I'll divide them. And the rule for division on exponents is subtract them. So I have a 3, and I have a 1 on the bottom. That leaves me with 2. The next guy had a plus sign there. So again, we treat them like three separate problems. So now I do the middle one. Divide the coefficients. 3 divided by 3 is 1. Don't have to write the 1, but I'll write it just for the heck of it. The x's in the middle problem here would cancel. 1 minus 1 leaves none. And I am stuck with that y, but I have simplified that guy as much as I can. So we just move on to the last one. Coefficients. 15 divided by 3 is 5. Subtract my exponents. I get a 2 on top. I get a 1 on the bottom. I subtract them and I get 1. So now we could check to see if we can add these together, but if the original problem we weren't able to add anything on the top, so we won't be able to add any of these at the end. So that's it. We're done. So not particularly tough, but again, I recommend taking the time to do this right here in the middle, in the box, and split them up into three different problems. All right, a couple more examples to look at. That one was already done for us, or partly done for us. So example number 1 here. And another reason I like to take the time to rewrite them, guys, is you've got a bunch of signs here to worry about. So if I were to just take the time and go, I know my 5np is getting divided by the bottom one. And I also know that the minus 10 n squared p is getting divided by the bottom one. And lastly, I know my 35, or my negative 35, minus 35, is also getting divided by that guy. So no, I mean, it does take a little extra time to do it, but it's going to make it way more likely that you get a correct answer. So three little problems to do. I simplify this one. 5 divided by negative 5 is negative 1. N's cancel, P's cancel. I'm done with that one. So again, here's why I like splitting it up. So you can see the middle one has a pair of negative signs, and a negative divided by a negative, we know, makes a positive. So 10 divided by 5 is 2. I have 2 n's and 1 n, which leaves 1. And 1p and 1p would cancel. 2 down, 1 to go. Again, a pair of negatives. Makes it a little easier to see that. So I get a plus 7. 2 n's and 1 n. Subtract the exponents, I leave with 1 n. 2 p's and 1 p. Subtract the exponents. I got 1 p left. And that's it. So again, I don't think these are too bad. You can skip or look down a little bit. Type 2 says long division. Those guys are kind of tough, but these ones aren't so bad. So another thing you can do, if it's written differently, it doesn't have a fraction bar, but the divide sign right here obviously implies that it's the same type of problem as that previous one. So we could be a little lazy, and we could say, I know my 21a is getting divided by 2ab. And I know this guy is getting divided by 2ab as well. So that saves a little bit of writing. Okay, now again, so 21 divided by 2. Well, I don't want to mix decimals and fractions, so I'm not going to write 10.5. So we want to treat 21 over 2 just like any other fraction. Can you reduce it or not? In this case, you can't, so we can just quit. So 1a and 1a. Now, here's, again, why taking time to write it this way is going to pay off. If you write it this way with the 2ab underneath, you can see plainly that the b that's left over is on the bottom. So just write them on the bottom. So we've done algebraic fractions like that before. No big deal. So the second one, I got a 2 divided by 2. Well, that's a 1. I got 3a's minus 1a, exponents that is, leaves 2. And I got 1b and 1b, which cancel. So we're done with that one. So nowhere does it say they have to come out with non-fractions. If you do a division problem, division can be fractions. So 21 over 2b, that's fine. Okay, number 3. So another way of writing it, again, mathematicians, they just like messing with you. Can't just do everything the same way every time. We got a little exponent of -1, and if you recall, negative exponents mean move it to the bottom. So if I move it to the bottom, well, it's a divide problem, and it looks like number 1. So I'm going to go ahead and be a little bit lazy. But I know that everything in that first polynomial is getting divided by 4RQ. So again, this is like splitting them up and making 3 separate problems. Best way to go, trust me on this one. Okay, 3 problems to do. First one, 12 divided by 4 is 3. Remembered an equal sign this time. Didn't on the last problem. I've got 2 r's on top and 1 r on the bottom. Subtract the exponents, leaves 1 r. 4 q's on top, 1 q on the bottom. Subtract the exponents, q to the third. Minus, got the next one. 8 divided by 4 is 2. 1 q on top, 1 q on the bottom, 1 r on the top, 1 r on the bottom. Those would all cancel. Middle one's done. So all I have left is a coefficient on that one. Last one, minus 4 divided by 4. Well, that's 1. So now here's where it gets a little bit interesting. But again, if you take the time to write it this way, I think it's way more obvious. I got 3 q's on top. I got 1 q on the bottom. I subtract the exponents. I get q squared. But that guy's gone, that guy's gone, the 4's are done. What about that r? I can't cancel with anything, and I can't just erase them, so I'm stuck with them. But if you take the time to write it this way, you're going to see that the r is on the bottom. And you're just going to write it on the bottom, so you're not going to miss it. All right, let's see here. There is no way I'm going to get the long division problem done in the minute and a half that I have left. So I'm going to save long division for part 2, which kind of makes sense. So that's split them up problems part 1. If you want to check out the long division problems, that will be in part 2. And the synthetic division problems probably will end up in part 4 video because I'm sure the long division is going to take 2. All right, guys, thanks for watching.